Hi everyone, welcome to our first video lesson on area. Today we're on 11.1, areas of parallelograms. Let's first define area so that we all know what we're talking about when we say the area of a certain figure. Area is the square units inside a figure. So I have two figures up here, and let's just say that this is 1 square inch right here. Okay, there is 1 square inch. So area is how many square inches fit inside this square. So there's 1, 2, 3, so on and so forth. How many of those square units fit inside that square? Here's a 7-sided figure called a heptagon. We might say how many square units fit inside this, right? So there's all different sorts of formulas, all different ways to derive the area of certain figures. Today, we're under area of parallelograms. So how do you find the area of a rectangle, which is one type of parallelogram? Well, if there are, let's say, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? If there are 10 square units, and then I have, let's say, 4 square units here, 1, 2, 3, 4, well, then I would have 10 in this row, 10 in this row, 10 in this row, 10 in this row. There would be 10 square units in each row, so there would be 40 square units, in our case, inches, right? 40 square inches. So the way that we get that, you've probably learned this at a very young age, you take the base, which is 10, times the height, which is 4. So how do you find the area of a rectangle? The area equals base times height. Some people say it's length times width, which is just fine as well. In my class, we more often use the terminology base times height. So if that's the area of a rectangle, how about any parallelogram, such as this one? Well, class, are you ready to be amazed? Here we have a blue parallelogram. Now what is it called? Hey-oh, it's called a rectangle, right? So wouldn't this parallelogram have the same area, the same square units as this rectangle? Of course it would, right? They're the same amount of space that's taken up between here and here. I just like doing this because it's so much fun. See, from here, to here, Isn't that kind of fun? Anyway, so the formula for the area of a parallelogram is the same for a rectangle. The area equals base times height. The one thing that you need to be very careful about is that the base and height are always, and you'll hear me say this many times this chapter, they're always perpendicular. So if this right here is 10 inches, and this over here is 30 inches, you don't take 30 times 10, that's not the area. The height is the perpendicular distance, that 90-degree angle right there. So we need to be careful about that as we go through. Such as this problem right here. Let's find the area and let's find the perimeter. I would say that the perimeter is a little bit easier, so let's maybe find that first. The perimeter. In a parallelogram, opposite sides are congruent, so 23, 23, 10, and 10. So the perimeter is 23 plus 23 plus 10 plus 10. Right? It's adding up all 4 sides, the distance around a figure. So 23, 46, 56, 66. 66 inches is the perimeter of this parallelogram. However, the area is how many square units fit inside. It is base times height. Well, I know the base. This distance right here is 23 inches. I do not know the height right now. The height is this distance, or this distance, or this distance. As long as it's perpendicular between the 2 parallel sides, I'm going to draw it strategically right there. This, friends, is going to be my height, right there. So, question for you, how do you get the height in a 45, 45, 90 right triangle, right? It shows up again, the 45, 45, 90. Well, this is the hypotenuse. So the hypotenuse is the square root of 2 longer than the legs. So if I want to get to the legs, my height is going to be the hypotenuse, 10, divided by the square root of 2. right? If I want to get to the legs, I multiply, or if I want to get to the hypotenuse, I multiply by root 2. If I want to get to the legs, I divide by root 2. So let's rationalize the denominator. So now 10 root 2 over 2. So my height is 5 square root 2. So the area of my parallelogram is base 23 times the height, which is 5 root 2. So what is 23 times 5 root 2? 23 times 5 is 115. So it would be 115 times the square root of 2. Or approximately, if you multiply 115 times root 2, you would get 162.63 square inches, or inches squared. Make sure you label with area, everybody. Labeling is very important. So that is our area. There is approximately 163 square inches that fit inside this parallelogram. 163 of those. Let's try another one. Here, again, the perimeter should be very simple. In a parallelogram, opposite sides are congruent. So there's 2 sides of 12 centimeters, and there's 2 sides of 15 centimeters. So you add up 12 plus 12 plus 15 plus 15, and you get 54 centimeters. Hopefully that's basic enough. The area, again, the area equals the base times the height. So the base is, once again, this side right here, which is 15. So 15 is our base. Our height is a little bit trickier to find. It is the perpendicular distance between the 2 parallel sides. So this right there. Now what do we have, everybody? If we have a 90 and a 60, that means this angle is 30. We have a 30, 60, 90 right triangle, don't we? The hypotenuse is 12. The longest side is 12. The shortest distance is half as much. The side opposite the 30 is half as much. So this side is 6. And then this side, our height, which we want to find, h, that's the square root of 3, bigger than the shortest side. So 6 times the square root of 3. There is my height. So what's my area? Base times the height. And height is 6 root 3. 15 times 6 root 3 is 90 root 3. That's my area. Or approximately, if we take 90 times the square root of 3, 155.88. This time it is centimeters squared. So there are 155.88 square centimeters inside this parallelogram. 155 of those. All right, the Andersons are planning to recarpet the first floor of their house. Find the amount of carpeting needed to cover the living room, the den, and the hall. Evidently, they want the same carpet in those 3 rooms. This is a common problem when you go to a Menards or a Home Depot kind of a place. They sell carpet in square feet. So let's find the area of all 3 rooms. The area of the living room is this. The area of the den is this. And the area of the hall is this. Well, the den, would you agree that the den is a rectangle? So it would be base times height, 15 times 9. The area of the den, oh shoot, I just did that, rats. Let's do this. This is the den. This is going to be the living room. So here's the area of the den. Here's the area of the living room. So I just did the den. The living room is right here. That is also a rectangle of 15 times 13. 15 times 13. And then what is the dimensions of the hall? The hall is right here. Well, this is 15. This is 15. Up here we see that it's 35. The length is 35. So that means this has to be 5 to make 35. And then the hall is the same width or height as the living room. So it'd be this 13. So it'd be a 5 by 13. 5 times 13. All right, what's the area of the den? 15 times 9. 15 times 9 is 135. The area of the living room is 15 times 13, which is 195. And the area of the hall is 5 times 13, which is 65. So if I am going to Menards or wherever the home improvement store is, and I want to ask for this much carpet, I would add up those 3 rooms, and I would say, sir, I need 395 square feet of carpet, please. I'd probably ask for 400 just in case I made a mistake while installing it. All right, 395 square feet. We'll do this one in class tomorrow, everybody. So I hope you have, I hope that you understand this lesson. Let me know if you have any questions when you get to class tomorrow.